Hello world, welcome to the stream. It's been a little while, but I apologize for that. But I have not been idle in the interim, so let's jump right in, and I'll show you where we've gotten to. Let's build this. So if you remember last time, we were building out our launch screen here, and I was working on getting the image to load, but there was an issue with the getting it to display properly. And I actually got it to display. It was all red tones, and I discovered that the representation of the color, the pixels in memory was reversed, and it's due to like big endian versus little endian. The way the bytes are actually referred to by the processor, so everything was kind of reversed. And I needed to kind of flip the bits around a little bit to get the colors, the actual colors, to show through. So I did that, and I was pretty excited about that. But then I said, why don't I take it a step further, because this is a classic ASCII roguelike. So right now you're not looking at ASCII, you're looking at a bitmap image with some ASCII characters over the top of it. So what I did, I thought it would be cool if you could take this bitmap image and convert it to ASCII. And so I spent several days kind of thinking about it and coming up with an algorithm, and we'll walk through the algorithm in a little bit. But I wanted to show you the output currently. So this is I built in a little bit of a toggle on this screen to toggle between graphic mode and ASCII mode, and I think I tied it to G. So this is the ASCIified version of the image. So you've got bitmap, and then you've got bitmap kind of converted to something drawn only with ASCII characters. I think it looks pretty cool. It's obviously blockier or whatever, but I think it's a pretty true representation of the original bitmap. So I'm pretty pleased with how that came out. And then you can jump right into the game, hit N, and then you're back in the game. And this part is we've been through before. So I wanted to walk real quickly through the code for that. So let's see, it's all in UI. So last stream we built out this view draw image at, and so what I did is I added a view draw ASCII image at, which will take this ASCII image structure, which I'll show you in a minute, and basically loop through it and draw each character to the screen with the proper colors and everything. So what is an ASCII image? ASCII image has the following properties. It's got an array of console cells, and then it's got basically just a number of rows and number of columns. And then the console cell we had already defined, because we already built out this console concept, and basically it's a glyph and the foreground color and the background color that glyph is going to be rendered with. So let's just walk quickly through the generation of this ASCII image. And so I have this routine ASCIify bitmap, and it will take the console that we are going to be drawing to eventually, because the console has the font information that we need. And then it takes the bitmap image that we have loaded. And basically, like the high level algorithm is this. We're breaking the given bitmap image into cells. If you remember, a cell in our console is defined as a 16 by 16 square of pixels. So, hey, Enraged, what's going on this evening? How are you? So the algorithm is, step one is to break that bitmap image into cells, and each cell is going to be 16 pixels by 16 pixels. And then what we're going to do is we're going to loop through each cell, and we're going to analyze each cell and figure out what the primary and secondary colors are. And basically, we're the algorithm there. I'm not going to dive into it too much. Basically, we're counting pixel colors. We're going to take the primary color is going to be the most seen color in that cell, and then the secondary color is going to be not necessarily the second most frequently occurring color. It also needs to be a certain distance away from the primary color, so that there's enough contrast between the primary and the secondary color. Because otherwise, if we just took the top two most frequent pixel colors, we would get colors that may be almost identical and indistinguishable. And so then that's not really useful for rendering it. So the image analyzed colors sends us a primary color and a secondary color that is distinct enough from the primary color. And then what we're going to do is we create a 1-bit representation. It's 1-bits in quotes because it's not a true 1-bit representation. We're using, I think, 32 bits to represent that, on-off condition, which is a little bit inefficient, but it's what we've got. Create a 1-bit representation of the graphic, which will indicate the shape of the cell. So basically what we do is we loop through each pixel in the original bitmap, and we can go into that. Loop through each pixel of the original bitmap and basically determine whether that pixel's color is closer to the primary color or closer to the secondary color. And if it's closer to the primary color, we set that particular pixel to, on, or in this case, I just set it to pure white. And then if it's closer to the secondary color, I set it to, all zeros. And I lost my spot. Where are we? Yep, there we are. Analyze colors. Alright, so I can get rid of this debug code. Don't need that anymore. Needed a lot of debug code to figure this out, let me tell you. So then, once we've got kind of our mask of what shape we're looking for, we try and match that shape to a glyph in our ASCII set. And we're not matching it. Originally, I was matching it to any glyph in the font. But the basically, I ended up restricting it to a fixed set of glyphs here. And all you can see all here. Basically, it's the list of glyphs that are. I'll just show you which ones they are. It's kind of hard to describe. So, basically, it's all the most pixelized glyph. Yeah, exactly, enraged. Let me see if I can pull that up. I don't have a window for this in OBS. Let me pull up an ASCII chart on the old interwebs. It's not gonna do it. Yeah, I'll have to show you another time. But basically, it's a limited subset of the glyphs that represent a certain portion of the given cell being filled with the primary color. So you may have, there's one where like the top left quarter is the primary color and the rest is secondary. There's one of those for each of the corners, and then there's one where it's like half. So basically you end up being able to section a single cell into smaller sections that allow you to get kind of a pixelization of the bitmap. So we loop through and find the glyph that best matches the mask that we've created. And then I'm lost again, lost in the weeds. There we are. So then what we do is, now that we've got that glyph, we create a console cell for that glyph, for the cell that we've just analyzed and determined what's what. And we set it with the glyph and the primary and secondary colors, and then we loop and go to the next cell, and we repeat that, rinse and repeat there, and we end up, again, let's show you real quick, we end up with, here's your bitmap, and then here's your ASCIified version of that bitmap. So I think it turned out pretty cool, and it's pretty satisfying to have puzzled that out over a couple days, and then to see it actually come together and look pretty decent, is satisfying. So tonight, I think what I'd like to do, I don't have a ton of time to stream tonight, but we've kind of, I think the launch screen is in pretty good shape. The obviously the menu options don't all work. Am I using that technique on other things? Well, that brings me to tonight's coding chunk. We have our launch screen, and then we have our in-game screen. What we don't have yet is an end-game screen, which is what we're going to show when the player dies. Right now, the player dies in-game and they just disappear, and it's still the in-game screen. So what I'd like to do is at least start putting together that end-game screen. We're not gonna finish that because I'm not even sure exactly what information I want to put on the end game screen. Typically in roguelikes, you if there are things in your inventory that were unidentified, you don't really know what they were or what their magical powers were. Typically on an end game screen, you're given the opportunity to have your things identified. How am I rendering these screens? So I built basically a software rendering engine that treats the screen as a classic console. It looks like it's all text on screen, but it's actually all, I'm drawing each pixel individually. And I'm using the SDL2 library to kind of give me that pixel buffer, and give me the cross-platformness of that pixel buffer. But the rendering itself is all it's all done in software. And if you are interested in following along at home, you can, there's a GitHub repo right there. The latest and greatest code is up there, and you can check it out, play along at home if you want, or modify it, or whatever you want. Yeah, SDL is pretty, again, I'm not using, I'm not even scratching the surface of the various features that SDL offers. I'm really just using it to give me a pixel buffer and to be able to do like double buffering, swapping, draw the graphics, and then the other thing I'm using it for is for input handling, so getting key presses, and I don't have any mouse functions planned yet, but if so, I'll certainly look at that. Got any suggestions on optimizing JavaScript for speed? I'm not like a hardcore JavaScript programmer, so not really. Why didn't I create those images in Photoshop and render the whole image? Oh, well, where's the challenge in that? Come on. Now, part of this whole project is really about, figuring out how this stuff works. Not using an engine or not really using too many prefab parts. And like really, I wasn't even planning to do that ASCIification of a bitmap. I was just going to create some bitmaps, or some ASCII screen and just, like you said, copy it. But then I was like, oh, that'd be cool. Why don't I just, it seemed like a fun problem to solve. So, I kind of went down that rabbit hole, and now I've got a reusable method that hopefully we will reuse to build our end game screen. Why not GPU accelerate it and use software to convert the generated image to text? Well, you could. Again, this project isn't about having the most accelerated or most optimized engine. It's really about coding the engine from scratch and just figuring out how all the pieces fit together. And then the scope of this project is fairly small because it's partially to get me familiar with coding in C, and or just thinking about things at a more granular level, at a lower level, and once this project is complete, I'll probably do a more serious, in-depth game. But right now, I'm just having fun with this. So let's add a new screen. Copy this stuff so I have kind of the same. This is going to be our end game screen. And what's today? Today is the 22nd. And we're going to save this as screen end game. And now there's we've kind of come up with a bit of a flash into ASCII for a couple seconds, then fade out. Yeah, that's kind of cool. It could be, that's the thing, now that we have this ASCIification, like we could have some cool special effect where yeah, exactly, like something got damaged, or it kind of, instead of shaking the screen, or maybe you shake the screen and it goes ASCII, or yeah, something like that. You can build that into, you can use that in different ways now that we have it built. It's a good idea. All right, so I am going to let's just figure out. We've got kind of a pattern of these different screen files. We have because in the screen file we have the code that will render that particular screen, and then we've got the code that will handle the events for that screen. So actually, I'm just going to copy maybe all this and then cut out the stuff I don't need. So let's move this over here. And we'll do key down. We're just going to clear this stuff out for now. Leave a to-do there for that. I'm not going to do this. Let's just do... We are going to do a background view. And then I'm going to do screen show. This will be end game. Just call it so I can do subviews. And so what we're doing is basically we're going to we need to create the views that make up our end game. And so in this case, we're going to do, let's see, what's our end game screen going to look like? We're going to have a background that we will be askifying a bitmap again. And then there'll probably be some other subview that is overlaid on that background, and it'll contain the information that we want to show for the end game. So I guess we'll start with two views. So this will be, let's call it info. It'll be our info view, and then we're going to need to define some constants to use. Something like this to make it look like it's showing on an 8-bit screen. Look at that 8-bit color. Let's see. I'm gonna do background. Let's do end game. I can't type tonight. End game. So the background's going to be 80 by 45, which is our full screen, because our full screen is 80 cells by 45 cells. We're actually rendering in 1280 by 720, but we cut it up into 16 by 16 cells. And then we're going to have our info view. So we'll do info, left, top, width and height. And I'm thinking it's going to be, I think the bitmap that I'm going to use has, it has like a skull. I was looking on, I found like a cool bitmap that has like a skull in the corner of the screen. So maybe we won't render the info view yet. We'll just get the background on there. See what's what. So our background rect is going to be, and view is going to be this, and then we pass it our. This is a function pointer to our render chain, and then we're going to insert the background view. active view. Right now, I guess. Render our background view. So now, what did I call the? I'm going to do a color effect to make it look like it's displaying on an old screen. I don't know that I want it to necessarily look like it's displaying on an old screen. I called it game over. How apt. So what we're going to do is we're going to load that file from the file, and then we're going to call our ASCII routine. And then if ASCII mode is set, we're going to draw it in ASCII mode. Otherwise, we're going to just draw it as a bitmap. And then we're going to not put this console string here because screen. So let's just load this up. Create our info view, and it's really just going to be, oh man, this keyboard, it's not my use. Code on a different shaped keyboard all day. Switching over to this, I always fat finger it. Okay, render, we're going to do render info view. Is our going to be the name of our rendering routine. And what we're going to do right now is we're just going to copy this info view. And we're not going to do anything in this right now yet. Alright, so next step, let's just make sure that this is, we replaced everything. Copy pasta, you always gotta be careful. Handle at endgame. Oh, if I return the actual variable I created. Okay, so so in our event handler, we're not going to handle any key presses yet, and for render info, we're not going to do anything in that render routine yet. Let's pop this into our game. Make sure we're including it. Double pound. Okay, so screen end game is what I called it, right? End score game. Okay, and it's not .h, it's .c. All right, so the last step here, let's make sure it builds. It's complaining. 24. 24, yes, I still have a copy pasta crap in there. And then I need to, I'm using these render functions here, but I need to define them, so. Or declare them, I guess, before I use them. Otherwise the compiler will not be happy. Okay. Let's build this. I still got a menu view in here somewhere. 40 there. End game. Okay. So it builds now. However, we're not actually calling this from anywhere, so we're going to need to put screen show endgame call to that in the right spot. So where do we handle our death code? Pretty sure I've got it to do it somewhere. Health, Google update, cover, health check death. Here we go. Enter endgame. I had it to do right there. So this is if the game object that is dead is our player, we add a message, you have died, and then maybe, do we want to, well, yeah, let's just throw it up for now. Build. Oh, I let's see. I need it declared. Oh, this is what I need. Set active screen. No, screen showing game. Let's try this. Yeah, I still need to declare that function. So let's declare it. All right, let's see what we got. All right, so we're in graphic mode for now, at least for the launch screen and the end game screen. Let's start a new game and kill. Oh good, there's a kobold, so that guy should kill us pretty quickly. Oh, we killed the kobold? That's not possible. Find more kobolds. Okay, get us both. Come on, goblin, get it done. Oh, and we crashed, so there's an issue. Thanks, Brother Pie. I'll check those out in a bit. Let's see what our issue is. Unhandled access violation reading location. Oh, it's not going to give me. Yeah, assembly language doesn't help right now. So we got call stack. What's going on, Visual Studio? Hello. Studio gonna lock up on? Yes. Oh, there we go. Oh, image. It's dying on the image load. Oh, that's weird. Did I not give it the right image name? Game over ping. Pretty sure that's it. Load. Sure I'm calling that right. Okay, well, let's... What's our data size? Image width? That's not right. That is not our image width. What the hell? Load? Component 7, this is just wrong. I wonder if it's not saved as a ping. Let's. Here's that code I was referring to earlier when we were. We need to swap. Need to check and see what system, the Indianness of the system that we're running on, and if so, that we need to rearrange our pixel bits. Which is kind of, if we don't do this, then all of our bitmaps end up looking red, like all tones of red. So sure what's going on. The only thing I can think of is that perhaps the ping is not stored properly. Stop the debugger. And maybe run it again with a breakpoint and attach to the process and see what's up. So let me attach now. Start. So that did work. So this is the case where we're doing our image ping, and that works just fine. Step over. Get image width of 1280, image height of 720, and then we get 4 components per pixel, which is totally correct. Continue. Start a new game. Kobold, die. Get us, Kobold, get us! Come on, Goblin. Alright, so we died. Our file name is game.ping. Step into this and see what's up. Did we get back F? Seems like we did. So let's see. Result is null. Okay. Yeah. I'm wondering if our ping is not good. Yeah, our image data is null, so we're getting that crap. Should probably put a check in there. You know, null, so we don't crash, but really I'd rather crash and no problem, right? So we can fix it, because it's not something that should happen during the course of running the game. I'm gonna open up that file in Can Paint even do pings? Can it save as a ping? Let's do save as. It says ping. Alright, I re-saved the file or re-exported it as a ping. Let's try this again. Get us, goblins, get us. Well, didn't make him too proud. My purposes, I did. Hit us. Just hit us once. Okay. There we go. Alright, so we... For some reason, that ping file was not saved properly or whatever. And so... it's actually drawing. Let's fix this. because it's actually rendering the view here. So the skull is kind of in the lower right-hand corner, so let's do it 10. Say 10. 10. Width will be 50. Height will be 30. Yeah. Save. All right, so that should get it out of the way of our. Right, come on, Cobalt, get us. Perfect. All right, so we still get a bit of an overlap with the view. We'll need to make it a little less wide, but let's put it in graphical mode and see what happens. That's. I like that. That looks pretty freaking cool. That algorithm works really well. I do say so myself. I'm gonna pat myself on the back for that one. The text render, you know, I wanted to put some text on this image just to see what would happen when the, you know, this font is kind of crazy. It's not gonna scale down very well, but I mean, it's almost readable. So I think either we pick a different font. I think we pick a different font and maybe even make it a little bit bigger so that scaling it down won't be so awful. But this skull looks wicked. I'm very pleased with that. Alright, so let's make the info width 40 so it's not going to block our awesome skull. And I'm actually going to buy the game over screen. See if I can quickly add a source to. Yes, so that you guys can see. There it is. Okay, so here's what we're working on. Let's get rid of this. Oh, it's not. Paint is really not the program, but it works for now. So we want to cut this. Let's try this again. Okay, and a font that kind of doesn't suck. Maybe like an impact. Let's pick a color that's so color. It's going to be this blood color. It's not a super great font. I don't know, we may not have to play around with these fonts a bit to find one that's really going to work. That's not awful. May work. Let's try this. Alright, let's give this a go. Can't get enough of that. Okay, get this goblin. Okay, this guy's got our... Alright, so we have our new image. Let's see what this looks like. That's not necessarily that much better. So maybe... I mean, the O looks cool. U isn't awful, but you know, the E is going to be a tough one to do in any font. And it kind of depends on you know, where the cells fall. So like some of the like this D looks different from this D because of where in the bigger bitmap how the cells are chopped up. Like this, the dots look different because of where the cells fall. Need another color on the text so it looks more aliased. Yeah, for the text, I mean, it may be that my Askify algorithm doesn't work great on text, and I think I'm okay with that because we can certainly put, like, can actually write text there if we want to. I don't know why this is still showing up. It's blocking. Save that file. File width is 4. I don't know, death metal maniac, that is something to ponder. Deep thoughts, man. So let's... Did I not build it? I didn't build it. Okay, so now we have our... It's not blocked. Now we can see the full skull render. It's pretty sweet. So maybe I'll, for now, just remove this text, or maybe I will. Maybe if it's like a really big. Try one time. And OBS's. Yeah, you like that? Sweet. It's paint that's messed up. That was weird. Okay, now it loaded. Okay. So we're gonna get rid of this. And then draw. we go with all caps because let's do that. If that looks bad, we'll just the text cells or something. Pile on. Goblin couldn't finish this off. Alright. Oh, you know, that doesn't look awful. It's not great, but I'm not thrilled with the text rendering, but that's fine. Cool. Oh, it's just about all the time that I have for this evening. So, but I think we got a decent chunk of stuff done. I like that we've tied in our end game screen, and so the next step is to figure out what kind of information we want to put in our info view and render that view. Final player stats, and then what maybe inventory or gold or whatever that the player has. Which kind of brings me to the next point, which is that we don't have any inventory to show in our info view yet because we haven't built the inventory system. Looking at our to-do list, looks like we did our in-game screen, we did our launch screen, and we just kind of put together a rudimentary end-game screen. I think we may put a menu option or some hotkey that allows them to start a game, which would take you back to screen. So that you don't have to exit the game and then relaunch it. But other than that, the endgame screen is kind of done enough for us to move on to our next step. So I'm going to mark this one done. So our GUI step is done for now. The rest is really just kind of building out the various screens and fleshing them out. But we are on to items and inventory. So I'm going to be off stream. I'm going to be thinking about what kind of data structures I'm going to be using for items, what kind of items we're going to want in the game, and how they're going to affect player stats. So I got a bit of thinking to do off stream, but we'll be back soon enough to start building out our item and inventory system. So thanks everyone for watching this evening. All of our archives of previous streams are up on YouTube, so check those out if you want to. I can be found on Twitter at PDCodes, and as I said earlier, all the source code is up on GitHub. I will be committing the changes from tonight momentarily, and you can check those out and play along at home if you want. And be sure to hit that follow button if you want to get notified the next time I go live. I stream several evenings a week, usually between 7 and 8. Usually start between 7 and 8 Pacific time. So Thank you for watching this evening, and I will see you again next time. Bye.